Everyone, hope you're all well and listen to teeth back in. Welcome to the first of your lesson 3 videos. Okay, we're going to cover a little bit of background on data quality, missing data, duplicate, and so on. And then I've got a couple of exercises based from 4 years of statistics from The Chase with Bradley Walsh. The data's a mess. It's amazing cleaning it up, but we'll get to that in a wee minute. Okay, doke. So, a little overview here. I'll get this thing to work. Here we go. Data quality. I don't know, we talked about The Chase 30 seconds ago. If you watch Bake Off, if you use crap ingredients, you'll have a soggy bottom, or your cake will fall apart. For people who haven't seen Bake Off, there's no point spending all this time on data analysis, transformation, visualization, and so on if your results are skewed because you haven't got quality data. There are all sorts of ways of minimizing, almost impossible to eliminate, but all sorts of ways of minimizing. We've got missing, duplicate, outliers, and inconsistent. I'm going to go through a little bit more of that. If you remember from last week when we were doing the difference between mean and median, when we're using big data sets, we tend to use median. Remember, median's the one in the middle, right in the middle, as opposed to the normal old average. And by doing that, that gets rid of some of the outliers. So inconsistent stuff stored in an inconsistent format. Okay. If I had 3 data sets from Edinburgh Council, Glasgow Council, and Birmingham Council, and I wanted to compare the wages of certain jobs within the council, and let's say in Glasgow, people who collect the bins are called bin men, and in Edinburgh they're called refuse collectors, and in Birmingham they're called bucket emptiers. Well, that's not consistent. I can't compare them against. So, I mean, that's a fairly obtuse example, but you understand what I mean. We've got some really good little links off to academic papers and blogs and things here. Please let me know if any of these aren't working. I've gone through and checked, but just let me know. Ideally, if you've got missing data, you want to try and replace it. Think about an Excel spreadsheet. If you've got a whole row and there's one cell missing, if we can replace that, if we have any way of researching or taking it from somewhere else, fantastic. And the last resort is delete the entire row. We don't want to leave one empty cell because that's going to muck up our averages and our counts and so on. But if we can replace it, ideal. If not, you remove the whole lot. Duplicate. All right, this happens. We're all working for big companies. This happens all the time. Multiple data collection. People miskey in things and so on. Outliers, inconsistent, a little bit more briefly there. And how to avoid. I should probably say, as I said earlier, how to minimize as opposed to how to avoid. Validate the input data. Okay, so in plain English, you've all done this. Whether you've created it yourself within Excel, but when you're filling a form in online and instead of it saying, oh, put in your job title, you have a drop-down list. That means that one of us couldn't say we're a lecturer or a college lecturer or an educator or it can only be one choice, which makes the analysis at the end so much more straightforward. Data standardization, you decide up front what format you want stuff kept in. Data dictionary, again, a data dictionary is like a sort of summary of what's gone into your data set. We've got data validation rules and so on. So that links in with the validate input data. So your validation rules will say, I don't know, the numbers can only be between 60 and 95 to save anybody miskeying. And if somebody accidentally miskeys that in, you'll get an error message or it won't allow you. I don't know how many of you play poker, wildcards. You've got various wildcards. The most simple one within Excel is the asterisk. If you've ever typed in your email into an online form and it's starting to tell you, oh, that's not a valid email, it might well be that they've got the simplest bit of validation there. It's asterisk, @ asterisk. And what that's saying is it can be absolutely anything and an @ sign and absolutely anything. And if it's that, it might just be an email. It should be more complicated than that, but that's a very simple one. Encourage collaboration between different departments. Yeah, we'll leave that one there, shall we? No, we should. honestly, a second set of eyes on things is invaluable. And, spread the work out a little bit. Okay, then. Hope you're all sitting comfortably. Structured versus unstructured data. Until reasonably recently, we only used to deal with structured data. Structured data is things that can fit nice and easy into a spreadsheet. Your name, your email, your address, your phone number, probably your credit card details. Anyway, I can compare one phone number against another. It all sits nice and neat in there. We know what we're looking for. However, the majority of what we create is unstructured. You've got a photo, an email. One person sends an email, it's very likely to be comparable to another. Photographs, you can get some data from. If it's a digital, I'm touching my phone here, you can't see what I'm doing, but anyway, I was pointing to my phone. If it was taken on your phone, you can get your location, probably IP address, size of the image, when it was taken, things like that. But it would still be, that probably fall more into semi-structured. But 80 to 90% of the data we create, or is created, shall we say, is unstructured. Another little statistic chuck at you. About 3 or 4 years ago, somebody came up with that 90% of the data ever created had been created in the previous 2 years. That statistic's still the same. So think about that say 4 or 5 years ago, whatever, 90% of the data ever created had been created in those 2 years. And then the year after that, 90% of the data ever created had been created in those 2 years, etc., etc. It's going exponentially up. You're in a great position where you're going at the moment, but we've got the processing power, we've got the storage that we can investigate structured and unstructured data. So I'll read through a little bit more of that. Organization, analysis, storage, and cost. Yes, obviously, structured data, nice and simple. It doesn't take up a lot of room, fits only. But unstructured, the storage, the analysis, and so on, much more expensive. Okay, now, this is a nice little H5P here. MongoDB is a very famous database, a very unfortunate name. So Ricky Gervais doesn't get hold of that, but it's a really good little breakdown. There we go, I'll just open it up for you. Remember, if you're opening these on your own pages, with it being H5P, there's quite a lot in there. It might take a few seconds or so to open. And it just gives you a little breakdown there of unstructured versus structured, and some examples and so on there. Worthwhile we read through there. That's a good little breakdown there. There we go, back here. Oops. There we go, back to the page. Right then. Structured and unstructured fits very nicely into qualitative and quantitative. My link's not usually that good, but it wasn't as tenuous as usual. Anyway, so structured and unstructured is easier to say and spell than quantitative and qualitative, but it's along those lines. So here we go. Qualitative data. Opinion-based. When you're doing surveys, you tend to try and have half and half, or at least I would have some quantitative, and the quantitative ones are specific numbers, statistics, answers, yes, no, whatever. Well, no, actually not yes, no, but specific, countable. Qualitative is more opinion-based. However, it's important when we're gathering data to have a bit of both. I'm actually on the side, I'm trying to get a qualitative survey turned into quantitative analysis. Okay, I'll try and explain. There was an experiment done last January, and it's on GitHub. And I wish I could remember his name. Anyway, not to worry. He analysed 1.25 million tweets about ChatGPT. And he ran a thing through it called sentiment analysis using AI. And it's something I'm trying to work on at the moment. Anyway, obviously tweets, they're not like a normal Likert scale. I'm sure you've come across that. I strongly agree, reasonably disagree, hate this, or whatever, the 5. Tweets are opinion-based, they've got email emojis and so on. So by running this sentiment analysis through them, they could get a rundown, percentage satisfaction, if you like, overall of what these tweets were saying. So I do feel it's important when we're asking surveys and so on that you have a mix of both. But when we're asking qualitative questions, the paradigms of what people think are either acceptable or good or bad, everyone's paradigms are slightly different. So then you back that up with the quantitative data as well. So the thing is though, and everybody gets tied up on this one, just because it's got numbers in it doesn't make it quantitative. For instance, I used to live at number 11, the Spinney. I can tell you that because I don't live there anymore. Number 11 is a qualitative description of the house. There's no guarantee that there are another 10 houses before me in that street. It's not a comparison of that against another. It's that house could be called, I don't know, Glen Burnie, which is the name of the house I live in now. Same if my hotel room is 302. That is qualitative. There's no reason for us to assume that there are another 301 rooms in that hotel. Hotel rooms, the first floor always starts at 1, second floor starts at 2, third floor starts at 3. There might be 3 rooms in each room. So just because it's got a number in it doesn't necessarily mean quantitative. If it can be counted using that number, that's fine. But if not, it might just be a description, qualitative. Qualitative. There we go. Now, this will do your head in. Sorry. But there's a little quantitative catch-up quiz, 21 questions. And as I said there, little hint, just because the description contains a number doesn't necessarily make it about quantity. So just bear that one in mind. Okay. Yes, now Dad will come in, flash fill. Nothing to do with Excel, but it's not, his name's not even Phil, but it's the closest I could find. One more short Excel for Power BI video to go through, with links on there. And then after that, I'll just show you. You've got your stats from the chase. Why? Because I love the chase. Also, when you see, in fact, I'll just show you now. When you see the list that it came from, just like that, there we go. And you don't have to download it. I've downloaded it all for you. It's a mess. Look through these various column headers and so on, and you've got, oops, there we go. You've got one column there, contestants, 4 sets of contestants all in there. If I wanted to find out, for instance, how successful each chaser was, I would need to find out, well, how much money was given away or not. So I would need to add up the contributions. How can I add up brackets and a plus sign and 20 grand and bracket? So anyway, the videos will take you through it. I hope you enjoy those ones. There are 2 videos in part 1, part 2 of that. Yeah, I enjoyed putting them together. We've had some really good feedback on those ones, but if there's anything that doesn't work for you or so on, please let us know as normal so we can get it fixed. All right, all the best. Speak to you in the next one. Bye.